Good morning, everyone. So today we're going to review combining like terms, and then we're going to extend it beyond what we've learned in the classroom in 6th grade to look at what this happens with when we subtract and when we have negative numbers. So we're going to do a short review, and then we're going to move on to some extension to help you with today's activity. Let's review a few key vocabulary words before we get started. So when we're talking about combining like terms, some of us don't understand, well, why is it called combining like terms and not like numbers? Well, terms do take into account coefficients and variables because each term is separated by an operation. So this 2x is a term, and also the 4y is a term, and also the 9. And these are the operations in between them. And then in each term, you have coefficients and variables unless it's a constant. And a constant means it is just a number that does not have a variable beside it, because we know the difference between variables and constants is a constant stays the same, where variables can change depending on what value you plug in for the variable. Okay, so the important thing to know is that these are all terms, but also that these three terms cannot be combined because they are not the same. These are x's, these are y's, and this is a constant. They're not the same, so we cannot put this together and say, oh, 6xy minus 9 or negative 3xy, because these are not all the same, so we cannot combine them. Let's do a few simple ones to review what we've learned this year. So a great way to remember what you can combine is to either color code or shape things that are terms that are alike. So in this one, we have our 6n and our 3n are both n's. The 5 is different because it has no n beside it, so it does not belong with the 6n and 3n. So we can add those two, and we have 9n plus 5. Okay, let's look at another one. So something that throws people off is when it's just x and there's no coefficient in front of it. So we could still combine our x's, and then our y's would combine. So see how the color coding helps me see, okay, I need to put these together and I need to put these together. So when I think of x plus 4x, I have to remember that this right here is the same as this. And it's a great way to remember that, okay, so I have 4x's plus this other x, that gives me 5x. So when x is by itself, it's understood that there is a 1 in front of it. Whether it's a negative or positive, if it's a variable by itself, there is an imaginary 1 or a hidden 1 in front of it. And then we have 2y plus 8y, which gives us 10y. And remember, that is as simple as we can make it because we cannot combine x and y's. They're not the same term. Now let's throw in some subtraction problems. So if we have this one, same thing. We're looking for those like terms. So this has an r, this has an r. Those go together. So when you have these subtraction signs, you could also rewrite it as plus a negative 5. And that might help some of us understand that minus 5 is the same thing as plus a negative 5. So we can combine our constants together here like that. So then we have 12r plus 3r, which gives us 15r. And then we have a positive 5 plus a negative 5, which actually just cancel each other out because 5 minus 5 is 0. So then our final answer would be 15r for this problem. Let's look at another problem with some subtraction. So this one, we have 8p plus 3n minus 4p minus n. Some of you, it might just be a good habit to just rewrite, let's go back to the white. We have 8p plus 3n, and then instead of making this minus 4p, we could rewrite it as plus a negative 4p plus a negative n. Okay, so then we combine our like terms, 8p with a negative 4p. So if I have 8p and a negative 4, or you could think of it as 8 minus the 4p, that would give me 4p. And then we have 3n plus a negative n or minus an n. So if you have 3 n's, remember there is the invisible 1 here. That would mean that I have 2n left over. And that would be our final answer for that problem. Okay, let's look at some negatives with subtracting. This is where rewriting the problem would be so helpful. So on this one, we have negative 12n minus 5n. So if I rewrite this, it's negative 12n plus a negative 5n. So you have to think, if I have negative 12n's and then I add another negative 5n, I would be at negative 17n. And the best way that I've learned to help students with understanding adding, subtracting negatives is if you think of like a number line, and you don't even have to draw it in detail, and I'm at negative 12 and I'm subtracting 5. Subtracting always goes down unless it's subtracting a negative. So if I'm going 5 more down, that would put me at negative 17. So I just wanted to cover that because you may see some of that. Let's do one more, and I'm going to kind of do a longer problem this time. Okay, so we have a little longer of a problem this time. So on this one, we have negative 5x plus 2y plus 8x plus 4 minus 5y. So first thing I notice is that we have 3 different types of terms that we're looking at. So I'm going to color code them first. So the first thing I want to do is color code. So this is my x, this is also an x, and that's the only x's. And then I'm going to color code here. This is a y, this 4 is not. And then notice when I circle this, I'm circling that subtraction sign to remind myself it's the minus the 5. It's not minus the 4. The way I always tell students is think about the way you say it. Are you saying minus 4 or are you saying minus 5y? And then lastly, we have this constant of 4 because it doesn't have a variable. So we know the 4 is just going to stay plus 4. So then let's connect our like terms. So we have negative 5x plus a positive 8. So if you think, once again, think about that number line. If you're at negative 5, to get to 0, you would have to go up 5. And then you still have 3 more to go up, so you'll end up at positive 3. So this would be 3, let's change back to white, 3x. Another way to think of it is you can flip and say, oh, 8x minus 5x also works. Okay, and then we have our y's. Sorry, I connected the wrong one there. There we go. 2y minus 5y. So I know that it's going to be negative because that minus 5y is greater than the 2y. Well, not greater, but has a greater absolute value, I should say. So if I'm at 2 and I'm dropping down 5, I'm actually going to end up at a negative 3y. So you can either write that as 3x minus 3y or 3x plus a negative 3y. On your activity, I think you need to write the subtraction though for it to count. And then 4 just gets dropped down. Okay, so the order is going to matter, I think, on the activity for my pre-AP students, prep students that are doing an activity after this. The order will matter, so make sure you keep them in the correct order. If you have any questions on the activity today, please reach out to me. I'll be more than happy to help. I hope you guys have a great day, and I hope this helped all the others. If you have any questions, please reach out. Have a great day.